And before we get started, we just have a few housekeeping items to go over. Today's session will be recorded, so if you're not comfortable, please drop, and we'll be sending out a recording within 24 hours. For any questions you have today during the webinar, use the Q&A box on the right-hand side of your screen. If they're related to the presentation, we'll answer those at the end. And also, we've added some additional documents on the right side of your screen where you'll see it says Docs, and those are relevant to today's presentation. So today's presenter is Aleksandr Nartovich, and I'm going to turn it over to him.
Thank you, Jennifer. Hello, everyone. My name is Aleksandr Nartovich, and I'm a pre-sales architect at Axway. I've been with Axway for over 7 years, dealing with APIs in different capacity at Axway. So today I'm going to present this webinar, which I titled like 5 practices to improve your API security. And before I start my presentation, I'll probably go stop my video to improve the overall performance of kind of switching slides. And when I'm done with my presentation, I come back and hopefully I'll have time to answer any questions that you may have. And with that, let us start. So in this presentation, I will recommend the overall API security approach for checking and adjusting your API gateway configuration. Not everything will apply to every organization, but it is a good set of checks that you should review and adjust as needed. You all joined this webinar because APIs become one of the communication mechanisms enabling applications and systems to interconnect. Surveys show that over 50% of organizations cite APIs security as one of the top 4 priorities, and over 70 customers are indicating that the security plays a significant role in their decision whether to integrate with a third-party API. So it's very important, and it's definitely rising in the importance as API becomes the mainstream communication channel between applications and systems. And let me begin with a story for you on the power of insecure APIs, power in quotes, one that serves as a cautionary lesson for any enterprise. It happened with a successful retailer with a booming online presence, and the company had many internal APIs that had minimal security. And one of them was crucial for tax calculating. The API team was updating the API with the latest improvements and capabilities, and the API was fully integrated in production within like 3 weeks. On one day, the products were presented or updated in the catalog on Tuesday, making it like a peak sales day, especially around lunchtime. And on one such Tuesday, at the end of the month, the disaster struck. Around 11 a.m., online sales plummeted to 0, and orders couldn't be processed. And the culprit of that was quickly identified. It was a tax calculation API that was unresponsive. So API team discovered that their API was under a denial of service attack and overwhelmed by a large number of requests. So it took them over 2 hours to mitigate the issue. Surprisingly, the DOS attack wasn't from an external hacker. It originated from a server within their own accounting department. And it just happened that an employee was running an end of the month report, generating a large number of requests to tax API and effectively crippling it. So the price tag for that misconfiguration was well over $1 million in lost sales. So that is just an illustration of a situation where the issue couldn't be classified even as an attack, yet that API had to be protected using an approaches that I'll present in this webinar. And the information I am about to present is not only my own experience, but it also an analysis, like a compilation of many different information articles from different vendors and customers. So it's a kind of a combination of different responses by people who are running APIs on a day-to-day basis. And we'll start with recommendation number one: be aware of what you have. And as probably you understand, you can protect only what you know. And the first point here is you need to establish a central access point for all of your APIs. And API gateways are the purpose-built solutions for that, to configure and manage API security, lifecycle monitoring, and troubleshooting. So centralizing all of your API access in one or a few points, like API gateways across your entire enterprise, allows you to have much better control, visibility, and the security over all your APIs. It also allows developers to be more agile because they don't need to keep up with the most recent attack vectors, because the gateway will protect their code. Again, this is maybe an obvious point for many, but not for everyone. And that's quite common that we see that not all APIs go through the central API gateway. Point number one is that you can protect only what you know. And with the time, IT departments have created many one-of-a-kind access points that are not visible to your API team. So you can use a dedicated solution to scan your network traffic and expose those hidden APIs that are established in different backend systems, but not properly controlled and exposed. In fact, according to one survey, 54% of companies are worried about ghost APIs. Those APIs that have been used, companies stopped using them, but didn't properly decommission. And those API may still be used from time to time. And if you're not aware of what's going on, it's very hard to protect those APIs. So with that dedicated solution, you can identify all of the traffic and understand what APIs are used and identify those that are not properly controlled and protected with your API gateway. And the last point here is, while not directly used in configuration security, a unified catalog of all your APIs will give you a great handle on understanding what you have at hand across not only your gateways, from different vendors, but also from code repositories. So at the same time, you can implement some security checks and measures at the unified catalog level. And for visual picture, I just used our Amplify platform marketplace, which allows you to have 360-degree visibility into your API program. And it implements API linting, so giving you a way to understand the quality of your APIs in terms of security and design compliance. So like an API program manager or architect can have a quick look at the quality of the APIs that are delivered by your different teams and have an overall control to stop not very well designed APIs. Okay, so moving to point number two, and that would be apply a layered security approach. Similar to one of the fables of Aesop, the father, his sons, and the bundle of sticks, where a father asked his sons first to break a bundle of sticks and then one by one to show them the strengths of unity. Applying a layered security approach is very, very important. In fact, API security greatly depends on the unity of all security layers involved in transaction processing. And the main security issue at many organizations is a poor security hygiene. And while this is the most basic category of security vulnerabilities, but it is also one of the most important ones, and failure to maintain good security hygiene can lead to major breaches that could have easily been prevented. So you need to establish a practice to regularly review and update your software stack. And of course, we start at the operating system level, your infrastructure, where you need to keep an update on your operating system and more often on the libraries that are involved in a transaction processing. So to always have up-to-date version of those libraries on which your API processing are relied. It goes also to firewall, where you need to establish only a specific ports and protocols to be used to access your APIs. Moving to the next level, what we call like a surface level, you need to establish or use the latest release of transport layer security that provides an encrypted transport channel for invoking APIs. It is also very important to enable web application firewall and establish the latest rule set version, at least like the OWASP top 10 API threads deployed in the WAF. And however, since this framework is extendable, you can add additional rules based on your own requirements and knowledge of the APIs that you run at your gateway. Next, we go to tweaks and security configuration in the API gateway itself. And the first is the layer that you configure at the global API security cluster. That includes some specific checks for letting only specific IP addresses to be used to access your API gateway, checking for some payloads characteristics, maybe setting the global throttling across your entire API gateway cluster, and other potential additional configuration levels on this layer. Moving to the next two layers, this is where you configure security at your API level. And of course, the most important one is to properly configure your inbound security. Choose a robust security settings like OAuth 2 for call authorization. And your API gateway should be able to integrate with your enterprise-wide IDP for proper security authorization. And of course, you should enable encryption. As an example, our gateway, like at Axway, we also have like a built-in authorization server. So some customers use a combination. They may have an enterprise-wide IDP, but also use it for some use cases, a built-in authorization server. But it's very, very important to properly choose the right and robust inbound security configuration for your APIs. And the last layer in the protection approach is at the method level. So you go one step down into granular approach to your security configuration, where you can apply a more strict security checks for APIs method dealing, for example, with the changing object content that is associated with maybe a specific HTTP verbs like post, put, or delete, and use a number of scopes to kind of dissect your clients and the access rights to different methods based on specific security requirements of your APIs. So remember that while some articles that you may see about, let's say, WAF or inbound security say that it's not enough to have a secure API gateway environment, yet when you combine all those security checks and establish that as a regular process, you greatly improve the overall security for your API gateways, because as I mentioned at the beginning with this fable, that the unity comes when you put defense into multiple layers. All right, moving to step number 3, or recommendation number 3, which is monitoring and threat mitigation. So it's all dealing with the potential threats that your API gateway may face as you expose your APIs to your clients. And the first recommendations here, it goes about error handling. So make sure that you create a custom error message that is returned in case of any error within your gateway not as sometimes you see like a stack of server issue returned back to the client, which expose some internal details of implementation of your gateway and API protection. The second one is rate limiting and quotas are intended to limit the number of requests to a particular service to conserve computational resources and ensure high availability. APIs that don't implement quotas or throttling can leave applications vulnerable to brute force attacks in which an attacker systematically guesses a password to gain access. And another typical problem is denial of service attack, in which an attacker floods an API with traffic to exhaust the resources of a downstream service and take it offline. And it is exactly the issue with the examples that I presented at the beginning of this webinar. The next part of this recommendation goes about IP whitelisting. And with this recommendation, you just restrict the access to a gateway from very few IP addresses, greatly decreasing the surface of attack from bad actors. I know that many of our customers configure like two gateways, one in DMZ, one in internal zone, and the one that is in internal zone accept requests from the API gateway in DMZ, thus dramatically cutting that, as I said, a surface for attackers. I already mentioned about web application firewalling. It prevents a lot of attacks that comes with injecting a certain type of malicious code in the parameters. And the last point is about logging and monitoring. So log records the details of all system activities. So it's important to enable logging for every service and infrastructure component in your environment, including APIs. But even small systems can generate millions of logs a day, making it very difficult to identify suspicious activity promptly. So teams should therefore augment their logging practices with a robust monitoring strategy to surface from the logs potential security breaches. And there are a number of solutions on the market today that applies artificial intelligence to identify some unusual patterns in API execution or unusual patterns of kind of dealing with data that flow through API gateway. Also, logs may contain some sensitive data which needs to be handled appropriately, like removed from logging to ensure that security and compliance of your solution with industry standards. Okay, moving to recommendation number 4. This one is dealing with data security and validation. And first is you need to pay special attention to managing HTTP headers because they play a very important role in the overall security of your solution. So for example, when a web client sends an initial request to an API, the response should have appropriate HTTP headers returned, including security headers. Those security headers give, for example, the browser instructions for safely interacting with the API. For instance, like HTTP strict transport security headers or access control and cross-origin resource policy headers. The latter one, for example, can prevent a valid client from being misused to perform API requests on behalf of a potentially malicious third parties. And on the contrary, some headers should be removed, and those headers usually reveal some details about your gateway configuration. And the examples of those headers are like server header or X redirect by header, and there are others. So there are websites where those recommendations list all potential headers that you need to look at in order to make sure that you use those headers properly. Point number two is input validation and data sanitization. So it goes kind of a step further from web application firewalling, where you, as the person who understands the logic and the usability of your API, should implement checks on all the input parameters and the payload. So quite often, malicious attackers use API parameters and query strings and body to inject some malicious code. So knowing what to expect, at what type of maybe formats you expect from input parameters, you need to establish a validation routine within your gateway. And same goes to the payload. If payloads are small and well-known formatted, you can write a policy that checks the payload. But quite often, the payload has either large or dynamically generated. So you need to enable an integration with ICAP server to do a real-time scanning of those payloads to make sure that no malicious code is injected in payload before you pass that payload to backend system for processing. And the last one is data redaction. Sometimes developers fail to protect sensitive properties on the server side and instead relied on the clients to filter them out, which leaves them accessible for malicious parties. So this vulnerability is known as excessive data exposure. So you, as a, let's say, API gateway administrator, understanding your API, should implement a data redaction. And for example, I know in our gateway, you can either fully remove some data parameters from the response, or obfuscate that information. For example, leave only the last 4 digits of credit card information that you return back to your client, thus making it safe, protecting your sensitive data from being exposed to the outside world. And the last but not least recommendation, which is not particularly like technical, but it goes about establishing a consistent practice in dealing with your APIs. And the first one is very important. You need to automate as much as possible deployment and configuration of your APIs using DevOps pipelines. That's extremely important because APIs are very dynamic. Many teams are kind of deploying or changing APIs on almost like a daily basis. So imagine how many chances those teams have if they run some manual steps to make a human injected error. So dealing with automation, you first kind of establish and test your DevOps pipeline, and then you just use that to do all the configuration, deployment, testing of the APIs through a DevOps. At Axway, we offer like CLI or APIs, and probably other vendors use the same, in order to allow developers to build pipelines to automate all the steps in API lifecycle. Point number 2, write a security-specific tests and run them with every promotion of your APIs, from like test to QA, from QA to production. So at least you have always a sanity check for your APIs. Also, probably not, I'm not sure if I've heard many customers talking about that, but it's important for successful deployment of your APIs to establish and implement a rollback procedure, because as I said, APIs are deployed very frequently, and I'm sure every company runs into a situation that they discover something is not right with their APIs. So if you have a well-established rollback procedure, so it's very quick and efficient to undo that step and quickly kind of go back to a previous version. And the last but not least, I always recommend this to every customer: treat your internal and external APIs with the same respect. Because there are two major reasons for that. First, I illustrated that with the example at the beginning of the webinar. If that team implemented this kind of respect policy to internal APIs, that failure didn't happen. In fact, many breaches happened not from directly exposing like APIs from outside. Quite often, hackers come through a backdoor and run some malicious code from within your internal network. So the request may come from your internal network, and if you don't protect those internal APIs, you run into a chance of exposing some sensitive data to those attacks. And the second important point, since APIs are really growing in importance, and I see many customers, they start small by exposing one to a few APIs to their partners or ecosystems. With the time, as they establish maturity and the APIs become more important, they start moving some of those internal APIs to be available to their clients and customers. So if you establish the same rigorous configuration and testing of your internal APIs as externals, that transition from being an internal API to become an external API becomes almost like a trivial task, and you can easily do that within like a few minutes to move an internal API to external. So those are 5 major points that I want to kind of make you aware of. And to wrap up my webinar, just to want to emphasize that API security is a crucial topic, especially now as APIs become the major vehicle for integrating not only internally within the same organization, but also externally with your cloud application and other solutions. And as a next step, you can review kind of your API strategy and kind of see if you implement all of the recommendations that I kind of provided in this webinar, and see if you maybe have some missing steps or you need to reconsider and redo some of the steps according to these recommendations. And with that, I want to say thank you to you and for attending this webinar. And I think we have maybe a couple of minutes for Q&A.
Okay, great. Hey, Aleksandr, thanks so much. Great content that you just shared with us. We do have 2 minutes, so let's jump into questions right away. And the first one is, what API issues do you see most often among your customers?
Okay, I think that goes, I think, well in the same recommendation that I see from OWASP top 10. Improper configuration for API authorization, especially at the method level. That is definitely a big issue. I think many customers tend to start with maybe quick kind of testing of APIs during their development cycle, and they use less maybe robust API security when they secure and configure the APIs, and then without reconsidering that approach, they move those APIs into production and they leave that less secure kind of protection on those APIs. That's number one, the biggest one. And the second, it goes also back to that example of not properly setting like throttling and quotas on the APIs, and it leads to over kind of load of the API gateways, kind of making the overall API response goes down. I think those two are probably the most typical and the most often kind of seen in my practice.
Awesome. And we are now out of time. So any questions submitted, we'll be sure to follow up directly with you. Thank you all for joining. Recording will come out within 24 hours. We'll reach out to all of you. I appreciate you spending the time today. And Aleksandr, thanks for sharing all that great insight with us and actionable items.
Thank you. Thank you for everyone who attended, and thank you to you, Jennifer.
Awesome. Thank you all. Bye-bye.
Thank you. Bye-bye.